Hi, I'm Brendan Burns, and I'm here to talk to you about the next generation of ARM templates with Project Bicep. And with me is Alex Frankel, who's going to give you a great demo of what we have in store.
Hey, everyone. Thanks, Brendan. Yeah, I'm really excited to share the progress we've made with Project Bicep in the past few months.
Fantastic. So I'm going to start by talking about what is Project Bicep. Fundamentally, Bicep is a transpiler. It is taking a new language, the Bicep language that we'll get into in a little bit. It translates that into ARM templates that you can then use just like you would use an ARM template any other time to deploy an application. The reason we did this is because we really wanted to ensure that there was only one path through to deploying on Azure. If you have multiple different languages, you could have situations where something is supported in one language, not supported in another. This should be a familiar idea to you if you've ever used TypeScript, which is a transpiled language that ultimately translates its representation down into JavaScript for execution in a JavaScript engine like Node or in your browser. So this whole idea of transpiling is really just about building a better interface, if you will, to an existing product like the ARM templates. So why did we do this? Well, the fundamental reason that we did this is we want customers who are experiencing Azure to have an awesome time managing their resources with infrastructure as code, right? And if people are already using Azure templates for infrastructure as code, we want it to be best in class. We want there to be no barriers to people moving from perhaps deploying things with the portal or deploying things with the CLI, moving all the way through to GitOps and infrastructure as code. And we know that with existing ARM templates, there have been some challenges for people. As this meme that was up on Reddit about a year ago shows, there's just some parts of describing your application as a template that are just hard to learn, or perhaps just things that you're just not very interested in. And I want to walk through some of the concrete things that we've done in Bicep to improve upon some of the pain that people have had when they've been using ARM templates. So if this is you facing ARM templates, be glad. We've taken your comments to heart, and we're actually doing quite a bit to improve the situation. First of all, we've taken out a lot of the noise that is associated with JSON. JSON really, at its fundamental level, was designed around machine communication. It was designed to be a data format that you used between a browser and a server to communicate data. It was never really intended for humans to read or for humans to write. That means there's a ton of just sort of extra commas and extra brackets and places where there's just noise that get in the way, frankly, of understanding what you're trying to do, and also get in the way of just typing what you want to get done. If you take a look on the left-hand side here, you see a Bicep file representing a particular deployment. And on the right-hand side, you see the equivalent ARM template JSON representation. You can immediately see that the Bicep representation is significantly more compact, more concise, and yet I think you'll also find it's still quite readable. Right? Being shorter isn't just the end-all be-all. If we got it down to, no new lines and a single, long string, it wouldn't be readable. It wouldn't be useful. It might be shorter, but ultimately what we're trying to do is get to conciseness, something where it's expressive, but also compact. And I think we've really managed to achieve that with Bicep by removing a lot of the boilerplate and a lot of the places where JSON kind of got in the way. Because it's the native ARM template language underneath that we're transpiling into, it means that every single service that you have in Azure is available to you on day zero. So the Bicep language can support any API that's presently in Azure, as well as any new APIs that are added to Azure on the day that they're released. Of course, with all tools, we strive to achieve this, but because Bicep has that native binding to the ARM template language, it's achieved automatically, and you have complete assurances that you have 100% coverage. And that's a great advantage as well. The other thing about templates that people have had a lot of problems with has been about modularity and code reuse. You can't sort of have a really great definition of a VM or of a web application and reuse that definition in a bunch of different places. With Bicep, we're actually introducing the notion of modules. And if you've ever used any other programming language, a module is a very common concept, all the way back to includes in the C programming language. The idea that you could take a piece of your code and break it out for reuse or break it out for abstraction has been just a fundamental way that we ensure that our code is readable. And with the modules in Bicep, you can achieve the same thing with your infrastructure as code and your template files. And not only that, but you can actually share these modules. You can put them up on GitHub. We can really build an ecosystem around easy to use pieces of templates, not just complete templates, but pieces that can be used to compose bigger templates. And when you combine that with the work on template specs that's in ARM, it becomes a really powerful way of doing modularity and code reuse. I think the other thing that we learned along the way is no matter how good your language is, the tooling that you build is actually the thing that really makes a difference. I, for example, can't program at this point without tab complete, without the red squiggly line. Every single program that I write compiles generally on the first time, not because I'm a brilliant programmer, but because the tools have made it so easy for me to see the errors before I even press the compile button. And so in addition to investing a lot into the Bicep language, we've invested a ton into VS Code tooling so that you'll have IntelliSense, you have a language server, you have tab completion to prevent you from making typos, from trying to deploy something with, for example, like a VM SKU that doesn't exist. There's just a ton of stuff that actually hopefully makes the Bicep language itself a real joy to work with in an editor that's been enlightened like VS Code. I think the other piece of this that's really great is that just like with ARM templates, all of the state management for these templates is stored up in Azure. It's stored in the cloud. That means that if you're collaborating across a team from someone on a device, especially in these COVID times when we're all in far-flung locations, it means collaboration around a single definition, a single deployment is incredibly easy. And especially when you combine Bicep templates that are stored in GitHub with a deployment that's stored in Azure, you really are, capable of doing everything that you need to do, even from something as simple as a stateless web browser or a tablet or even your phone. And that's, again, a great feeling knowing that when you deploy that Bicep template, no matter what happens to your machine, if it falls in a lake or falls off a 10-story building, the deployment is still going to succeed. So when we think about this in general, we get a lot of questions about why we are trying to do this. And I think hopefully I've talked through a lot of our motivations, a lot of the pain points that we've seen. But there are still some specific questions that we see people asking. Like, why are you bothering to create a new language? Why not use something that's pre-existing? For example, why not invest more in Terraform? And the truth is that we look through all of these different options. There's a ton of great innovation happening out there in the infrastructure as code space, from people who are using native programming languages to express their infrastructure through to Terraform and other open source solutions. But really what we wanted to do is we knew we had this audience of ARM template users out there, and we wanted to reduce the pain that they were seeing, provide a lower barrier to entry into Azure, and then also just provide an abstraction above the existing infrastructure so that everybody who is using either Bicep or ARM templates could benefit from innovation inside of Azure. As I mentioned before, there's a ton of innovation happening in the infrastructure as code space in general, and we're not trying to be the one language to rule them all. We actually really want all of those different solutions to work awesome on Azure. We believe fundamentally that just like there's not one programming language, there's never going to be one config language. But we're really proud of what we've done in Bicep and how we believe that it's going to give you a best-of-class infrastructure as code experience on Azure. And to show you a little bit more about that and give you details of the Bicep language, I'm going to hand it over to Alex.
Okay, thanks, Brendan. So before we get into all the details of what's new in this 0.3 release, which we're really excited to launch today, I want to give a little context and kind of where we've been and how we got here. So back in August-ish, we released the 0.1 of Bicep, and it was open source from day one. And it was really primitive. We really just got it out there as soon as we had something that you could play with. And that was really to get the community involved as early as possible and to indicate kind of how we're thinking about this space and what this could look like in the future. But it was really, really primitive. You could just do a handful of scenarios that you could accomplish in ARM templates. But it did show kind of the syntax that we were driving towards. 0.2, which came a couple months later, was a really important release for us because we started consuming all of the Azure resource types. So every Azure team publishes a REST API spec, a Swagger spec, exactly which properties every resource type is expecting. And we consume all of that in Bicep. We started doing that with 0.2, and that is what powers a pretty complex type system that does all this validation for you, all the tooling that Brendan was talking about. This is really where that experience was starting to shine. We also introduced modules and code formatting and a couple of other features. But there were always missing things. And we have been talking about for a while now that this 0.3 release is really going to be the point at which we start encouraging people to start moving their ARM templates into Bicep in a production manner, because we're going to have parity with ARM templates. And so that's the kind of big exciting thing, is that we now have parity. We introduced conditionals, and we've now introduced looping. And I'm really excited to demo looping a little bit later. So there shouldn't be anything blocking you from moving from ARM templates to Bicep. If you're happy with where you're at with ARM templates, there's no rush, there's no urgency, but you should be able to switch when you're ready. Brendan did talk about how Bicep is fundamentally a transpiler. Now, that meant up until today, you've had to do that build step yourself. And so you would go through this step test loop of writing some code, building, and then deploying. Now the Bicep CLI is integrated into both Azure CLI and Azure PowerShell. And all that means is you can deploy your .bicep file extensions directly, and we will transpile it for you under the covers and send it to ARM on your behalf. You don't have to see a JSON file as part of that process anymore. We have a decompiler now, so if you are ready to switch, we, in kind of a best effort way, will take your ARM template and convert it into Bicep code. And it actually does a really good job, way better than I thought it was going to be able to do. So you can really take a lot of your ARM templates and just run it through the decompiler and have a starting point. It's ultimately machine-generated code, so you may want to refactor some names and things like that, but it's a pretty good jumpstart. And last, but arguably most importantly, it's now supported by Microsoft support plans. So if you are ready to take a dependency on Bicep in a production manner, our support staff is ready to go. They are now trained up on Bicep, and they can debug issues with you, and they can solve problems. So we are going to walk through some demos. We're going to walk through kind of the most basic Bicep code that you can author, and we're going to kind of up the complexity as we go. So I'm going to start by creating a simple Bicep file. So we're going to create an app service plan. So I'm going to create a file to start out called applan.bicep. And when I do that, because it's a .bicep file extension, VS Code immediately knows what it is. So it recognizes that it's the Bicep language. And the reason for that is because I have the Bicep Visual Studio Code extension installed, and you can go and get that today. Let's start typing a simple resource. That's ultimately what we're here for. The way it's structured is I have a resource keyword, and then I have what we sometimes call a symbolic name or a resource identifier. So I'm going to call this app plan. I could have called it my app plan. I could have called this foo. It's just a symbol. And then immediately I'm starting to get help from VS Code IntelliSense. So I get a list of all the resource types that are available in Azure today and all the API versions. So I want a server farm is what this is called. And I'm going to get the most recent API version. And I can just hit enter, and I get the whole type string spelled out for me. And then I do equals, and then I do an object. And all the properties that I need for a resource in Bicep are the same that I would need in an ARM template. So it needs a name, and we can call this just app plan for now. It needs a location. And actually, let's just use the resource group's location. So I have this resource group function, and I can get the resource group location. I need some other properties, so I'm able to load in all the expected values for this resource. So I need a kind, which is going to be Linux, and I need a SKU, which is an object, and the SKU has a name property, and the SKU I want is B1, so I want a basic plan. And then I have properties, and the only property that I need is the reserve property, which is a Boolean, and I'm just going to set that to true. And so this is a valid deployable Bicep file. And I have the Bicep CLI installed, so I can run Bicep build on this file, applan.bicep. And when I do that, I get the JSON generated. So I just went through that transpile process that Brendan detailed. Let's see if we can make this a little easier to read. And you can see the Bicep on the left and the equivalent ARM template on the right. And obviously, we just removed all that JSON noise that we were discussing earlier. I probably want to make this a little more dynamic, a little more parameterized. So let's create a couple of parameters. So I use the keyword param, and let's have one called name prefix, and it's going to be a string. And I don't want to set a default value because I want users to have to input what they want their name prefix to be. But I also may want to parameterize the SKU. So I have a parameter called SKU, and this is also going to be a string. But in this case, I want it to have a default value. So I can just do equals B1, and that's overridable, but that is the default value. So this becomes an optional parameter. So let's use that name prefix parameter. We're going to use string interpolation to include this in the name. If you've seen string interpolation in any other language, this should look very familiar. It's certainly a lot easier than writing concat functions, which is what you've had to do in ARM templates. And then I'll just replace the SKU hard-coded value with the parameter. And notice I don't need any brackets. I don't need a variables or parameters function in order to do this. And then the last thing I need is an output. So I want to output the app plan's ID so that when I'm adding websites to it, I have that reference and I can point it and wire them together. So I'm going to say output plan ID. This is a string. And then I can just say equals app plan. So this is a reference to that symbolic name. And I can say .id, and I can get any property from the app plan, but all I need is the ID. And so I don't need the resource ID function anymore. I can just pull the ID with .property access, similar to what I would expect in kind of any modern programming language. So I'll save that, and we can build it and get a sense for what this looks like. And fundamentally, it's the same idea. So I'm seeing my ARM template. It's a lot more complicated, relatively speaking now. I have a lot more functions, and I need to kind of parse what's going on here. But fundamentally, at this point, the JSON is more like a binary or a build artifact. You certainly can look under the covers and see what this looks like, but you don't have to. So let's close this out, and let's deploy this. So this is going to be a resource that lives in a resource group, like most resources in Azure. Historically, users have created the resource group kind of out of band. So they would create the resource group in a pipeline or locally, and then they would deploy the template to that. But one of the things that we've made a lot easier in Bicep is the ability to create the resource group and then target the deployment to that resource group. So let's create another file. We'll call this one main. The first thing I'm going to set is something called the target scope. This is optional. So by default, this value is set to resource group. So our previous app plan Bicep file, it's a resource group scoped Bicep file. But in this case, we want to target the subscription. So I'm going to select subscription here. And then I'm going to create my resource group resource. So I'm going to do resource RG, and then I'm going to just search for resource groups, pick the most recent API version. And resource groups are simple. So we'll say a.frank bicep, and we need a location, and we will just use the deployment.location property. So when you create a deployment, there's a location associated with it. So now I don't have to hard code that in the file. And then the next thing I'm going to do is add something called a module. So there's another keyword called module. I'm going to call this app plan deploy. And this is really just a pointer to another Bicep file. So this is where that modularity story and that code reuse story comes in. And you're seeing that I have IntelliSense even showing me what files I have relative to this main.bicep file. So we'll say equals, open bracket, just like a resource declaration. And I need a few things. So if I do control space, I can see what properties are required. Modules have a name, so we can just call this app plan deploy. And then I have params, which I'll get to in a second, but I have this thing called scope. And scope is where the module is going to be deployed. And you can see with VS Code, it's telling me I'm expecting a resource group here. So I can just do scope and then set it to the RG that we just created. And that's all I need to do. Now I'll just fill in the params. And we just have the name prefix that we set to be required earlier, and we'll just say a.frank here as well. I've been transpiling to the JSON so that you can see the JSON, but I'm frankly sick of doing that. I just want to deploy the Bicep files. So let's delete this other JSON, just so you know I'm not pulling any tricks here. And let's use the AZ CLI. So we'll do AZ deployment sub create, and that's the command to create a subscription level deployment. We'll do -f, which is the file that I want to point to, and now I'm going to say main.bicep. So it's a bicep file extension, it's not a JSON file extension. And I need a location, so -L for location, I'll say East US. And then I'm going to do -C. -C means confirm. And what confirm does is it's going to do a what if. It's going to do a preview of the deployment before I actually have to kick it off. So it's going to take what it thinks I'm going to do. It's going to go and talk to Azure and say, do any of these resources exist? If so, tell me the current state so I can do the comparison. Now, these resources don't exist. So in a few seconds, this is going to come back and be all green, showing me that I have 2 resources that are going to be created. So I have my resource group, and I have my app service plan. And it has the properties that I set, which are mostly hard-coded, so none of this is particularly surprising, but I can see it all there. Normally, I would say Y here for yes, but I'm going to say no because we're going to add a little bit more to it. So you may have noticed I have this very convenient folder called Good ARM Templates, and I have a website ARM template here. This is a typical ARM template deployment. It just has the website, and it's going to do a container-based website deployment. So it's going to point to a particular Docker image that's in Docker Hub in this case. I could have also used ACR, but I'm going to use Docker Hub for this one. Now, I don't want to rewrite this by hand, so I'm going to use, within AZCLI, I have the bicep command as well. So I'm going to say AZ bicep decompile. And I'm going to say -f. And I'm going to point to good ARM templates, site.json, and we're going to decompile it. So we're going to take it from an ARM template and turn it into a bicep file. And we can see here I get basically what I would expect. I have just the one resource of the website and all the same properties, just stripped of all the JSON noise, basically. And I can consume this as is. So I'm going to move it out of the good ARM templates folder because it's not an ARM template. And so now it's a top level file here. And we're going to have another module. So we're going to say module site deploy. And we're going to do site.bicep in this case. And this is also going to have a name, so we'll call this site deploy. This is also going to have a scope. So we're going to say RG, same exact story. And then I have params here as well. So what params do I have available to me? I have the app plan ID, so I definitely need that. I need to wire these things together. So I'm going to actually get the output from the app plan module. So app plan deploy dot outputs dot plan ID. And so now these two things are wired together as I need them to be. I need a name prefix, so we'll say a.frank here as well. And I need a Docker image, and this is nginx demo/hello. And then I have a tag, which is going to be latest. So this is going to pull the latest version of this container. This works, not particularly exciting. It's deploying a website on top of an app service plan. These are things I would expect to be able to do, but it's pretty clean and it's a pretty simple file, consuming 2 modules in about 25 lines. Pretty easy to read, pretty easy to consume. What I might want to do is have multiple websites. And so up until 0.3, we haven't had the capability of looping, but with 0.3, we do have ARM template parity. So we can actually loop through a set of objects and create a website for each one accordingly. So let's create a variable. We'll call it websites. And it's going to be an array. And it's going to be an array of objects. And we're going to have fancy. And it's going to have a tag of latest. And then we're going to have one called plain. And it's going to have a tag of plain text. Now I'm going to take my module that I've already authored, and I'm going to tweak it a little bit so that I have my loop syntax here. So I'm surrounding the module declaration in brackets, and that's going to tell Bicep that this is going to be a set of modules, not a single module. And I'm just going to type for site in websites, colon. And now my validation errors go away, but I'm not using this site anywhere. So this is my iterator. This is the current object that I'm looping through, basically. And I can use this as expected. So let's append the site name to the deployment name. Let's do string interpolation. And I can see site is in the IntelliSense list. So I can do site.name. The name prefix, we'll just replace this entirely with site.name. And then for the image tag, we'll just do site.tag. And now I have a modularized and loops set of resources here. So I'm going to create 2 websites in this particular case. So let's deploy this and let's verify that this is doing what we expect it to. So we'll do the same command as before. AZ deployment sub create, pointing to the same file, same location. I'm going to get rid of -c because I feel pretty confident in this deployment. And we'll kick it off, and then we'll switch over to the portal to make sure that this is deployed successfully as expected. So we'll click on our resource group, and I see my app service plan is already starting to show up. And we'll wait for the website to finish deploying, and we'll go and log into both of those websites and make sure that it's showing up as expected. Okay, cool. So I have my fancy site and my plain site. Let's take a look at them and see why they're fancy and why they're not. Cool. So we have our fancy site, and this is fancy HTML. And then we have our plain site. Same exact information, different website. And it's all in plain text. So you can see how easy it is to really start building complex Bicep projects and start tying them all together with IntelliSense. And as your needs grow and as your complexity grows, Bicep really scales with you. Okay, so that was all the improvements of Bicep that are part of our 0.3 release. And you can try it and contribute to it today. So if you just want to kick the tires with Bicep, you likely already have Bicep as part of your CLI install if you have the most recent CLI or PowerShell release. And then in VS Code, you can just search for it in the extension marketplace. You can get the Bicep extension. And as a matter of fact, now if you open a Bicep file in VS Code, we'll actually recommend this extension for you. So it's pretty easy to onboard. And if you do want to contribute, and a contribution really can be anything. It can be an issue getting created, it can be a documentation PR, or it can be a feature PR. All that stuff really, at the end of the day, helps us make Bicep better. So you can go check out the repo. All the information you need to contribute should be there. So please do check that out whenever you can. We do have our Azure Connection program. So we have an ARM and Project Bicep deployments community. So if you do want to join that community, you can use that link. It's another good community where you can get answers to your questions. If we're not answering it, there's usually another customer or whoever that's able to answer your questions. And with that, I just wanted to say thank you. Thank you for joining this session. Thank you, Brendan, for giving everyone great context on why we're doing the Bicep project in the first place. And the biggest thank you really to the community for taking up Bicep and making it what it is. So we've just seen a tremendous response in terms of issues being filed and lots of PRs, way more PRs than I was expecting. You are all the reason why Bicep is making the progress that it is. I hope you enjoyed this window into kind of where we're at with the Bicep project.